Today we are going to discuss about memory addressing by 8051. The memory types are illustrated in the following graphics. They are on-chip memory, external memory, and external RAM. On-chip memory refers to any memory that is either code memory or RAM or other that physically exists on the microcontroller itself. External code memory is the code or program memory that resides off chip. This is often in form of an external EEPROM. External RAM is a RAM memory that resides off chip. This is often in the form of standard static RAM or flash RAM. The total memory of an 8051 system is logically divided into program memory and data memory. Program memory stores the programs to be executed. The data memory stores the data like intermediate results, variables, and constant required for the execution of the program. Program memory is invariably implemented using EEPROM because it stores only program code which is to be executed, and thus it need not be written into. In the data memory, mainly it may be read from or written to, and thus it is implemented using RAM. Further, the program memory and data memory both may be categorized as on-chip, that means internal, and external memory, depending upon whether the memory physically exists on the chip or it is externally interfaced. The 8051 can address 4 kilobytes of on-chip program memory. Here is address 4 kilobytes on chip program memory, and its address map starts from 00H2 0000H2 0FFFH, and address 64 kilobytes of external program memory under the control of PSEN bar signal, whose address map is from 00 to FFFFH. Here it may be noted that the map of internal program memory overlap with that of the external program memory. However, these two memory space can be distinguished using PSEN bar signal. In the case of ROM-less version of 8051, the PSEN bar signal is used to access the external program memory. So, 8051 supports 64 kilobytes of external data memory, whose map starts from 0000 to FFFFH. This external data memory can be accessed under the control of register DPTR, which stores the address for external data memory access. 8051 generates read bar and write bar signal during external data memory access. The chip select line of external data memory may be derived from the address lines in the case of other microprocessors. Internal data memory of 8051 consists of two parts. Is here, this is the internal data memory of 8051 and consists of two parts. First is the RAM block of 128 bytes. Some cases it has 256 bytes, and second set of RAM address is, first one is 0 to 7F and second set address from 80 to FF, which include the addresses allotted to special functional register. Here the address map of 8051 internal 128 byte RAM starts from 00 and ends is 7F. This RAM can be addressed by using direct or indirect addressing modes. However, the special function registers address map is from starting from 80H to FFH, and it is only accessible using direct addressing mode. In some cases, some 8051 uses 256 bytes of on-chip RAM, that is 128 bytes and upper 128 bytes, that is total 256 bytes. In this case, here the lower RAM is size from 00 to 7F, but the total size is from 00 to FFF. If it is 256, it starts from 00 to FFF. In that case, the address map of special function register starts from 80 to FFH, which is overlapped with the upper 128 bytes. It also starts from 8 to FFH. So the way of addressing is here, the way of addressing is different, but it's in the safe special function registers it is direct addressing only, but in this case of upper 128 byte, here it is indirect addressing mode. So we are differentiating between these two memory space using this addressing mode. If it is an indirect addressing mode, then it is upper 128 byte RAM. Otherwise, it is a direct addressing mode, then it is a SFR. Here, the internal RAM memory, there are 128 bytes of internal RAM memory in the 8051 and assigned address from 00 to 7F. This is the 128 byte RAM, internal RAM, and this 128 bytes are divided into three groups. And first group, a total of 32 byte location starts from 00 to 1F are set aside for registers bank and the stack, that is here. And the next section, there are 4 banks are there, and second section, a total of 16 byte from location 20H to 2FH are set aside for bit addressable read write memory. Here it is. First section is 32 bytes. Here it is 32 bytes. Then it consists of 4 banks. Next section is a 16 byte and it is a bit addressable area. Then next one, a total of 80 bytes from location 30H to 7F, and it is used for read and write storage and as scratch pad. So general purpose area. Then these 4 registers bank are here: bank 0, bank 1, bank 2, bank 3, and it is a 8051 uses 8 general purpose registers R0 to R7, and these registers used in the instruction such as add a comma R2. Here add the value contained in the R2 into the accumulator. So here R2 happens to be memory location 02H in the internal RAM. The following instruction have the same effect as the above. Add a comma 02H. Then second one, bit addressable RAM 20H to 2FH, and here it supports special features which is allows access to bit variable where the memory bits in the internal RAM can be set or cleared. So a bit variable can be set with a command such as setb, and it is cleared command using CLR. So setb 25H, set the bit 25H, it becomes 1. Clear 25H clears the bit 25H. 25H is the location and its value becomes cleared to 0. Then bit addressable or byte addressable location are shown here. And third portion is general purpose RAM. These 80 bytes of internal RAM memory are available for general purpose data storage, and it is access to this area of memory is fast compared to access to the main memory. And however, these 80 bytes are used by the system stack, and in practice little space is left for general purpose or general storage. Here data memory RAM, external RAM, ഇത്രയും നേരം നമ്മൾ പറഞ്ഞത് ഇന്റേണൽ റാം ആണ്. ഇന്റേണൽ റാം 3 ടൈപ്സ് ഉണ്ട്, 3 സെക്ഷൻസ് ഉണ്ട്. ദെൻ 3 സെക്ഷൻസ് പറഞ്ഞു. ഇനി നെക്സ്റ്റ് വൺ ഈസ് എക്സ്റ്റേണൽ റാം. ഹിയർ 8051 support 64 kilobytes external data memory. It ranges from 00 to FFFH, and it is accessed by DPTR, and it generates read write during external access. And CS chip select can be derived from the address lines. Here name suggests that external RAM is any random access memory which is off chip. Since the memory is off chip, it is not as flexible in terms of accessing and is also slower. So for example, to increment the internal RAM location 14 by 1, it requires only one instruction and one instruction cycle. But to increment a byte, 1 byte value stored in external RAM requires 4 instruction and 7 instruction cycle. So this is the main difference. If we increment the internal RAM, it only requires one instruction and one instruction cycle. But to increase 1 byte value stored in external RAM, it requires how many instructions? 4 instructions are required and 7 instruction cycles are required. Then next move on to external or program memory. Program memory or ROM. ROM is a read-only memory, and 805 can address 4 kilobytes of on-chip memory. There are two types of memories are there, on-chip memory and off-chip memory. So in the on-chip memory, its size is 4 kilobytes and it starts from 00 to 0FFFH, and it can be address external memory up to 64 kilobytes and it starts from 00 to FFFH. And memory map of internal and external program may overlap. The internal and external ROM is distinguished by the signal PSEN. Here, in the case of a 4 kilobytes of internal ROM, this is a internal ROM, and 4 kilobytes of here, we are using a 4 kilobytes of internal ROM, and that is inside the chip. So the address space is starts from 00 to 0FFH. That is 4 kilobytes. If the address space, that is the program address, exceed this value, if it is greater than 0FFH, then the CPU will automatically fetch the code from external program memory. So it supports for 64 kilobytes. If the size of the program memory is greater than 0FFH, then it directly fetch the instruction or code from the external memory. For this, it uses a pin known as external access pin, and it must be pulled high. If the external access pin goes too high, then CPU fetches the instruction from the internal program memory in the address range from 00 to FFFH. So if EA bar is equal to 1, then it fetches the instruction from the internal program memory. If the memory address exceeds the limit, if it is greater than 0FFH, then the instructions are fetched the external ROM in the address ranges from 100 to FFH. Then EA bar goes to low. This is an example. Here it is an internal program memory. Its size is 4 KB and it ranges from 00 to 0FFF. Then EA pin goes to high, and there is an external program memory. Its size is 64 kilobytes and it starts from 100 to FFH. Total it starts from 00 to FFFH. And there is another way to fetch the instruction. If we ignore this internal ROM and fetch all the instruction only from the external memory, then EA bar is connected to ground. And in this case, the memory address of the external ROM starts from 00 to FFF. That is, external memory is 64K. If it is used, starts from 00 to FFF. If we are only using external memory, then it starts from 00 to FFF. If we use internal memory also, then here 00 to FFFH up to that memory location is overlapped in both memory. This is the structure of program memory map. Here the internal memory is when EA bar is equal to 1, it starts from 00 to 0FFH, and this is an external memory. Then at that time EA bar is equal to 0 and its overlap memory is 00 to 0FFH, and the external memory that is after 0FFH is 100H and FFFH. Here it is EA bar is equal to 0, and here external memory is accessed using another signal PSEN bar. That's all about memory addressing